It's question show time. Your questions, my answers. As always, wherever you are on my channel, question pops in your brain, just write it down, I'll gather them up, and I'll answer them here. It's too cold and windy outside to use our outside green screen, so we're going to use our inside green screen this week. Now, I've got a different format for our guest question. In fact, those of you who followed along with the live stream that we did with Paul Geithner from James Webb, you already saw this conversation, but this is one of the most common questions that I get asked about James Webb. Why can't we refuel it? And Paul and I get into that, and so we've sort of taken that chunk from the interview and made it better and added it to this. So if you never get a chance to see those, this is what you're missing. All right, let's get into it. Uncle Vinny. Hey Fraser, love your show. Could you talk a little about how it is that we see some meteor showers at the same time every year? I think I can visualize it, streaks of debris running across the orbit of the sun around the galaxy, but I'm not sure how and why. Meteor showers are mostly caused by the trails of comets as they're left through the solar system. So a comet goes around and around the sun, leaves a trail of debris behind it, and you can imagine it's this ring of material that exactly matches the path that the comet takes. And then the Earth orbits the sun, and some of those comets, the Earth passes through that trail. And so when you think about the Earth's orbit around the sun, right, we go through all of the seasons, and so we pass through these trails at the same time every year. And in some cases, we're a little above, a little below, a little to, not exactly head on hitting the trail of debris. And so that defines how strong the meteor shower is going to be from our perspective. If we have a direct hit right through this trail of debris at the same time that we've got a new moon, then we have the chance of getting a meteor storm where there can be hundreds, sometimes even thousands of meteors every minute. So most of the time it's sort of like you can kind of imagine this cloud that's getting ever wider, and yet there's still this kind of core. And if we pass right through it, then we get the best meteor storms. And one of the meteor showers is caused by asteroid debris. But essentially, it's the same process for all of them. And then, of course, there are always just random chunks of meteorites or meteoroids that are striking the atmosphere and causing meteors. So that's why we see them at the same time every year. F13 Media. 3D printing them out would be amazing. Also, you ship the parts that aren't printable for assembly by the robot arm, and the 3D printer prints the other frame parts. So not surprisingly, a bunch of the questions and comments this week will be coming from some of the space telescope construction episodes that we've done. And so the most recent episode that we did was about this idea of assembling space telescopes in space. Say over the course of 12 launches, you build a 20-meter space telescope in space from a bunch of parts. And this is just constructing the pieces on the ground, launching them into space, and then assembling them together into your space telescope using robotic arms. But if you use some of the other technologies I've mentioned about 3D printing, about 3D printing trusses, 3D spraying, solar panels, then you can get even less launches, more telescope, more bang for the buck. And actually, when I was interviewing the scientists and preparing this episode, I did talk to them about this idea of not just in-space assembly, but in-space manufacturing. And they said that that's a really exciting technology. They're looking at that, but they didn't even include that in this report. They're looking at assembly first, and then if they can get assembly down, robotic assembly, then they'll look at robotic manufacturing. But all these technologies are all happening at the same time, and you're going to see them as they're in different levels of maturity get bundled together to make future telescopes easier, more powerful, bigger, etc. Rams 495. They should start designing telescopes for the Starship. I mentioned briefly in the episode that even, say, LUVOIR might be almost too big to fit inside Starship, SpaceX Starship. And the Starship is going to have a 9-meter launch fairing. And I've seen some mock-up renders of what LUVOIR would look like inside Starship. And it's almost like James Webb inside the Ariane 5, but next scale up. And LUVAR would be the practical limit pretty much for what you could fit inside a Starship. But then you'd have all those problems of all those actuators and all of those parts that need to work perfectly, and light components and composite components and things like that to fit inside this single launch fairing. Well, if Starship is as inexpensive as people are hoping for, maybe it can launch all the separate components for a fraction of the price, even if they're much bigger and heavier, and then they get assembled in space. So I think that we're going to see future telescopes just get constructed using this in-space assembly methodology. And the other thing, I mean, a lot of people were just very dismissive or saying, like, let's just wait for Starship, right? And I don't think it makes a lot of sense to just wait for Starship. That absolutely the Falcon Heavy launches now and the 3 boosters attempt to land simultaneously. That's incredible. But Falcon Heavy took a lot longer than anyone was expecting. Same thing with a lot of the work that SpaceX has been doing. Ideally, I mean, SpaceX, Elon Musk says that Starship will do prototype flights in a couple of months. It'll start doing orbital flights next year. But this is still the future. And there are all kinds of things that might turn out to be a lot more difficult. And so it doesn't make sense to pause your development waiting for a future launch spacecraft to be built. We've seen this happen before. So I think that until that spacecraft actually is done and it's working and it's safe and it's dependable and we've seen a lot of launches with it, it makes sense to hedge your bets and design for this smaller launch fairing, which is this industry standard, right? All of the current big rockets, all of the planned rockets except for Starship are going to use that 5-meter fairing. And so if it turns out the Starship comes along and it's a tenth the price to launch, then you just put your 5-meter fairing spacecraft inside the 8-meter fairing of the Starship. It still fits, it's still cheap, and you launch it. So I think that you can cover all your bases just by aiming for that industry standard 5-meter, and then if Starship comes along, use the bigger launch fairing. It's not a big problem. Scott Shepard. For all the science programs waiting on these government-supplied telescopes, is there a policy barrier to paying a private-backed science tool? The way that observatories work right now, most of the time, is that a country or an international collaboration or a space agency puts in the money to build the telescope, space telescope, observatory, instrument, and then launches this thing to space or builds it in Chile or whatever. But then ongoing use of that instrument is freely available to any astronomer that puts in an application and they get their time approved. So if you're a researcher and you are, say, looking to study extragalactic clouds of dust or gas, you write your paper, you use that paper to request time on James Webb, and then they give you time on James Webb for free. You then you tell them when you want those images taken. James Webb takes the images, you get it dropped into a file folder that you get access to, and then you can write up your science results. And so you don't directly have to pay for time on the telescope. And I mean, there could be ones out there, but I don't know of any observatories that actually charge you to be able to use them. So what you're proposing is really a completely different way of being able to get some of this science done. You would figure out your science paper, you would then, and I mean, this already happens anyway, like you need to go and get funding from, say, the Sloan Foundation or the National Science Foundation to help just pay for your time to do the research. But then in addition, you would need to acquire funding to be able to pay for the time on the telescope. And it might be that that actually makes a ton of sense and that you can pay $100,000 to get the time on some gigantic space telescope to be able to get your research done. And that might be the cheapest way to get your work done. So I don't know of any telescopes that work that way, and no one's ever tried it that I know of. So, but maybe that exists in other fields. So any scientists watching, if you would you be able to do your research if you had to pay for time on the telescope? Do you already pay for time on the telescope? I'd love to hear what is the current landscape is and what the response to that would be. Jorge Julius Mireles. Can glass like telescope mirrors and lenses be manufactured from lunar regolith or other pieces for telescopes? Is there iron and carbon for steel in lunar regolith? How about Martian regolith? Let's get those interplanetary factories working already. There are plenty of raw materials on the moon and on Mars that you could use to build a telescope. There's tons of iron, there's tons of aluminum, and then even other more precious elements. Silicon, there's silicon oxide, so you could build glass. So a lot of the things that you might want to require, they're all there. But the key is manufacturing them in that location. Just like imagine how complicated and difficult it would be to hoist all of the parts to build a factory on the moon so that you could build a mirror, and look at the tolerances that are required and think about how difficult it is to minimize dust and other material getting in and causing problems as the mirrors are being ground and things like that. Makes sense to do that stuff here on Earth and fly it to space. Just every kilogram taken to space from here on Earth costs you $5,000 to $10,000. To do that on the moon costs you, say, $50,000 to $100,000. So we're not at the point yet where there's enough infrastructure on places like the moon, or especially Mars, that it makes sense to build these things locally. But eventually, as there's a research station there, as there's 3D printers in these locations, then you can see more and more of these future facilities being built in situ, on location. João Gonçalves. I don't understand why they don't use the space station as a staging area for the assembly of a next generation telescope or other installations. They're missing a very relevant role for the space station. I got this question quite a bit, and people say, the space station came together, was assembled in various parts. Why not just use that as a place, as a dry dock, as a space dock for building future things that you want to build in space? And absolutely, right? If you wanted to, you could have various parts of some future space telescope launched up to the International Space Station. The astronauts could work with the robotic arms to assemble things. If there's a problem, they could go outside the station and they could manipulate it directly and fix problems and get the whole thing there and working, and then push it away and off it goes into space. But the pushing it away, off it goes into space part is not so simple, because the International Space Station has a very specific orbit that is taken. It's going 28,000 kilometers per hour around the Earth in a very low orbit. And that is an entirely different orbit from the kind of orbit that you would need to get yourself all the way out to, say, geosynchronous orbit or out to the Earth-Sun L2 Lagrange point. You would need a lot of energy to make a change in velocity to be able to do that. And so up until this point, it's just made the most sense to launch your telescope in one launch, the whole thing, put it into its perfect orbit, and then have it unfurl and do its job. And so you might be able to have a simpler solution to assemble the telescope, but then you still have an enormous expense, and it's very complicated to move this telescope to its new location. And that's why the report that I was talking about was saying, well, could we kind of do both, where you send all the parts to the right orbit and then you assemble it there with robots, plug and play, to make the whole telescope work. And that would hopefully be the most efficient path to do everything. David is Costa Rica. Next space telescope needs to be on the far side of the moon. The problem with building a telescope, especially an infrared observatory on the moon, is the moon is still illuminated for half of the time, right? There is no dark side of the moon. There's the far side of the moon, and on the far side of the moon is still in sunlight half of the time. Now, the one place that you could put these telescopes on the moon is at the permanently shadowed craters. There's ones at the moon's south pole and probably at the moon's north pole as well. And so you put one of these telescopes in one of those craters, it never sees sunlight. The temperature never rises. It's always cold. It's perfectly blocked from the sun. But at the south pole, it can only observe the southern skies. It can never look up through the moon and see what's above it. And then vice versa, if you put one at the north side of the moon. Now you can put one telescope at the north side of the moon, one telescope at the south side of the moon. That would be great. But again, you have these problems of getting all this stuff out to the moon, landing on the moon, making sure that it's nice and safe and stable. So until then, space telescopes still make a ton of sense. If you can only have one telescope, send it to the L2 point. Maxileg. That means Andromeda is much closer than what we see on a telescope. I get this question a lot. People say, oh, well, if Andromeda is 2.5 million light years away and we're observing it, and then for the time that it took the light to get here, it's been moving towards us, and so it'll already be here. And so should it be a lot bigger in the sky? Well, Andromeda is moving towards us at 110 kilometers per second, which is really fast. That's like more than 3 times the speed that the Earth is going around the sun. But if you multiply 110 kilometers per second times 2.5 million years, I really like Wolfram Alpha to do this, so go ahead and do the math. You get about 916 light years. So over the course of 2.5 million years, so the time that it took Andromeda light to get here, Andromeda has only moved towards us 916 light years, which is a fraction of that 2.5 million light years that it is away from us. So you wouldn't be able to tell. It's a tiny little bit closer than when the light left it. So in general, all the objects out there that you see in the universe are roughly the same place, look the same, and they haven't moved very far. Mildromedion. We should be spending money on making life better and on equal living conditions level for all of the people in the world. Again, I get this comment all the time, which is like, why are we spending money on James Webb when we should be spending money on making everyone's lives better? Why spend any money on anything? Now, I mean, the first part is like, I don't understand why so many people are making these comments in my YouTube videos about space. Like, do you both love space but also hate that money gets spent on it? I don't really understand. So if someone can explain that to me, I would love that. But again, as I mentioned last week, think about all the ways that money gets spent on Earth. Military, $1 trillion. I think just by like that alone is dozens of times more money than gets spent on space exploration. Cigarettes, right? Like, I forget what the number is on that, like billions and billions of dollars. Takeout pizza, those are the 3 that I always use as examples. But you could just go on and on with ridiculous, wasteful, counterproductive, environment ruining things that people spend their money on. But why is it just science or telescopes, or whatever's like a large amount of money? And I think of all the things that you could spend money on that don't make humanity any better, the one thing that does seem to be delivering a more equal existence for as much of humanity as possible is science, right? And education. We now live, even the poorest people in many countries lives a better standard of living than the richest people hundreds, thousands of years ago. And that is because of science, because of research into new materials and health and basic physics and lasers, right? We don't know what lasers are going to be used for, but money was spent to try and research them. We don't know what exploring the solar system is going to be used for. But just of all the possible things that people can spend money on, science seems to be like the one of the few that is almost guaranteed to give us some general benefits for humanity. So whenever anyone says, well, like, why are we spending this money on science or telescopes or whatever when we could be spending it on help cleaning up the environment, making people's lives better, I always just have to respond. Like, what about military? What about cigarettes? Like take your pick. There's just too many ways that people spend their money that are harmful. So don't take away science. John Byrne. I like to take photos of the moon. Well, the other day I looked and it was a quarter moon, but in the photo it was a full moon. Is this a gift to me? Yeah, you got a free 3/4 of a moon. No, so what you're seeing in your photograph is actually the illumination from the Earth that is reflecting off of the moon. So you've got the light from the sun is hitting the Earth, it's reflecting off of the Earth, because the Earth is actually pretty bright. and it is striking the moon, and it's illuminating the dark side. In this case, it really is a dark side of the moon. And the term for this is called earthshine, and you can see it in a lot of photographs. In some cases, astronomers will overexpose the side of the moon that's being illuminated by the sun, and that will reveal the earth shine. Or you can go the other way, and you can turn down the exposure so you can just see the side of the moon that's illuminated, and that makes the darker portion of the moon too dark to be able to see. But I love this idea that we can actually see part of the moon because of the reflected light off the earth. And there's some really great ideas on how you could use that to understand exoplanets as well. One idea is that you would actually look at the moons orbiting other planets, detect the amount of light, the amount of planet shine on that moon, and use that to essentially reverse calculate how many continents there are, how much oceans there are on these other worlds. So it's a cool idea here on Earth, but also it would be a useful tool to be able to study exoplanets, which is doubly awesome. All right, time for the guest question part. Now, this was a segment of a live stream that we did with Paul Geithner from James Webb, and we talked about how it could be possible to refuel James Webb and what facilities are on board. And so you're going to sort of see every version of that question asked to Paul, and so hopefully we will now understand fully and deeply what it'll take to replenish James Webb should the need arise. Question from Corey S. Is there any way to stow anything on JWST after it's deployed if SpaceX Starship is able to go out and do repairs in the future or retrieve it? So this is, that's just a version, but the question that we get a lot is there any, the repairs and upgrades that were done to Hubble were so wonderful.
Yep.
I know there are no plans, but what capacity, what is possible? I'm sure somebody has done a back of the envelope idea for what it might take to be able to go out and not necessarily upgrade it, but at least give it more fuel to lengthen its mission.
Yes. So, it's a good question because I've worked on, my first job in NASA was working on Hubble servicing. And so I appreciate what servicing is done for Hubble.
Yeah.
My first job at NASA was working on the corrective optics for Hubble. So I've worked on CoStar, which corrected for the axial instruments, and I worked on NICMOS. Webb is hard to service, but we did think because it's a cryogenic spacecraft. Half of it faces the sun and is hot, but most of the mass of the observatory is running at 40 Kelvin. So servicing it in its operational condition is, it's rather impractical, but that doesn't mean servicing is completely impossible. So one thing we have done, and that you mentioned, is we didn't preclude the ability for somebody in the future to go, say, put more fuel on it. The one thing that will limit Webb's life guaranteed is fuel. The reason we need fuel is for station keeping and momentum management. And Hubble doesn't have fuel, but it's in low Earth orbit within the Earth's magnetic field, so it can react against the magnetic field of the Earth to do momentum dumps for its reaction wheels, which is how it points, like Webb. And it doesn't really have orbit maintenance. When we had the shuttle, we used to give it a reboost every time. But Hubble's in an orbit that's good for many years to come. So, but with Webb, we're way outside the Earth's magnetic field. We have to use something to react. So we use reaction jets. And of course, L2 is a metastable point. It's not a garbage collection point, so to speak, like L4 and
L5. Yeah.
So we need fuel to maintain our orbit and for momentum management. And so it's the one thing that could limit our life. So we've made sure that Webb is a cooperative target for someone in the future, maybe with a robotic spacecraft, to go out and acquire us and be able to put fuel through our fill and drain valves and put more fuel on it. But as far as changing out instruments or working on the cold side, that's just never been a practical consideration.
But there's two parts to it, right? There is as you say, there is the fuel for maintaining, for station keeping at the L2 point. And there's also the helium coolant that's being used to bring the telescope down to its operating temperature for the mid-infrared stuff.
Right, the mid-infrared detector has a but that's a closed cycle cryocooler. So it's like your refrigerator at home, only a lot more expensive.
But it does have a limited lifespan, doesn't it? For the amount of time.
No. Theoretically, it's.
Oh, really? Okay.
Yeah, it's closed cycle. It's like the compressor that runs your freezer and refrigerator in your house, except we're using helium for working fluid as opposed to like a fluorocarbon or something.
But there is like the refuel valve, and as you said, the intake and output are on the exterior of the spacecraft, and in theory, a very careful, very cold spacecraft could attempt to give it some more operating fuel. There's a place to clamp on if it needs to.
Yeah, the we have a standard launch interface ring. They come in standard sizes. We're one of those standard sizes, so a robot could go out, clamp onto the ring, and then our drain and fill ports are those are known locations. And by the way, these are all on the bus, which is always in the sunshine.
Right.
So you're talking a warm bus, always in the sunshine. It's not we're placing targets on blankets that can be used so that something that would acquire Webb would know its orientation. So yeah, we're making it a cooperative target, and we're providing all the information needed for somebody in the future to know how to basically unscrew the caps, put fuel in, and screw it back on.
And it's not like that ring is weightless. I mean, you had to account for that weight as part of and putting that ring on the spacecraft is perhaps payload that might not have been something else. So it's I mean, it's there anyway because we had that's how we attached to the launch. That's how we attached to the launch vehicle. Oh, I see. So it is the thing that you would be using for the Ariane for the upper stage anyway. So you might as well. Right. So that is there and
interface so somebody else can use it. We thought about servicing a long time ago. Webb's mission and architecture makes it really difficult. But the one thing that guarantees it will only last a finite amount of time is fuel. And so we've made sure it's a cooperative target. If somebody figures out a way to go out and stick more fuel on it, we didn't preclude that as an option.
All right, thanks, Paul, for taking the time to do that live stream. Again, we do these live streams every Monday on my channel. I know sticking around, having your, hanging out for an hour with me and a special guest, people don't have time for that. So if you miss the live streams on YouTube, you can always watch them after the fact. And I also make them available on the podcast edition. So if you haven't already, just do a search for Universe Today podcast, and I put all of the audio of all of those live streams there as well. So if you're too busy or you want to listen to it while you're commuting or mowing the lawn, there's your chance. All right. That was super fun. As always, wherever you are across my channel, question pops in your brain, write it down, gather them up, I answer them here, and I'll see you next week.